So our next question is course schedule 2. It is the upgraded version of course schedule first video. So the question state that there are total of num courses and you have to take labeled from 0 to num courses minus 1 means we have given the num courses number of nodes. So we have also given the array of prerequisite where prerequisite I equal to AI BI indicates that you must take course BI first if you want to take course AI. Means if we want to take course AI, then first we have to take BI course. Means like if we are in 11th, if we are in 11th means we are in class 11th, so then first we have to complete the class 10th. After class 10th, we can only go to the class 11th. So this is our funda. So for example, the pair 0 comma 1 indicate that to take course 0 means if we want to take course 0, we first finish the course 1. So we have to return the ordering of the course you should take to finish all the courses. If there are many valid answers, return any of them. If impossible to finish all the courses, return the empty array. Means we have to return the order in such way that we can finish all the courses without any problem. It can be multiple orders, so we have to return any of them. If no order, then we have to return the empty array. So this is our problem. So this problem is based on two topics. First is cycle detection, then topo sort, topological sort. Two questions. Means topological sort can only be done if there are no cycle means our graph is DAG, directed acyclic graph. Then topological sort can be worked. So how we will proceed? Like we have given this question. If we see example number 2, num courses are 4 means there are 4 nodes. So let's draw the nodes 0, 1, 2 and 3. There are 4 nodes. So the order R means if we want to finish 1 then we have to finish 0. Means we can say that if we want to finish 1 then we have to finish 0. So arrow will be like this means after 0 then we can only finish 1 and again given key 2 comma 0 means after 0 we can finish the 2 then after 0 we can finish the 2 3 comma 1 after 1 we can finish the 3 and after 2 we can finish the 3. So this is our given condition. So how we will proceed, like we will check that is there are any cycle in the given courses. Means if like course 3, course 2 and course 1. Course 3 is dependent on course 2. Course 2 is dependent on course 1. Course 1 is dependent on course 3. So you can see it forms a cycle. So no answer will be in this case. So this is unsolvable case. It is cyclic case. But in this answer, you can see there are no cycle. Means we start from 0, then we can go 1 or we can go 2. From 1, we can only go 3. And from 2, we can only go 3. So in this case, if first we finish the 0, then only we can finish the 1 or 2. And after finishing 1 or 2, we can finish the 3. So according to topological sort, it is value 1 and 2 is dependent on 0, then 0 will first complete. After that, we can make 1 or 2 like this because they are only dependent on 0 and 0 is already finished. So we can make this. 3 is only complete if 1 and 2 are already completed, then only 3 is completed. So in both case 1 and 2 are already completed, then 3 will be completed. So this can be our answer. Means there can be multiple answer. We can written either this or this. If there are any cycle, means if in this graph, like we have given this graph, then how we will return the answer? In this graph, we will return an empty array. If we found our answer, then we will return this value. This is our solution. So let's see how we will find our answer. To solve this problem, we have to first check two condition, means it will be solved in two steps. First step is a cycle and second step is topological sort. So first we will detect is there are any cycle in this graph. Then we will, if there are no cycle, then we will topologically sort this and return the value. Like in the previous graph, 0, 1, 2, 3, after 0, 1, after 0, 2, after 2, 3, and 1. So we have given this graph. So how we will solve? We will first check a cycle that is present in this graph or not. We can check cycle by a simple method. We will create two array. One is visited and other is our recursion stack. If we are start iterating for from 2, we go to the 1. Like we assume that there is no path from this and this is connected to like this. So in visited we have 0. We go to the 0. We go to in recursion stack, we go to the 0. So 0 is push our recursion stack. Then from 0 we go to the 1, we go to the 1. Then from 1 we again go to the 0. So 0 repeated. So there are a cycle. Means if a value is repeated in a recursion stack, means there are a cycle. From this path will continuously remain and this will repeat till the end. So in this way we can detect the cycle. So first we write the code to detect the cycle. Then after detecting the cycle, we do the topological sort. So how we will do the topological sort? We create a visited array. Similarly, that is previously created for a node like 0, 1, 2, 3. Then we will create a stack. We will create a stack. We start from 0. We will mark it visited, means it is visited. We will push it into the stack. How many element it has? It has two element, 1 and 2. It has two elements. So all its element will be pushed into the stack. Means it has two elements. So 1 will be pushed into the stack. Then it has two element 2 will be the push into the stack. So all its adjacent element are pushed into the stack. Then we will process the top of the element. Means it is pushed into the stack. It is also pushed into the stack. Then process top of the element. Then 3 is also pushed into the our stack. Then our stack is like this. Then we will pop from value stop and arrange in the answer list by reverse order. Means we will arrange like first we will pop 3, then we will pop 2, then we will pop 1, then we will pop 0. In this way we will return our answer. So let's check the code for it. Let me zoom. So this is our function find order. First we create a adjacency list, means we create that how many node are at 0, how many node are connected to node 1. So we create adjacency list. Then for this is part of creation of the adjacency list. Then we created a visited array. Then we create a recursion stack for cycle detection and another stack for our answer. Then create a result that will be returned. So first we check that if I is not visited and is cycle, means if there are any cycle present in the given graph, then we will return a empty array. Then we will return a empty array. Otherwise, we will make visited all value false and then we will proceed for the topological sort. So first we will see how we will detect the cycle. So in this cycle, we will get adjacency list, our visited array, our recursion and our current value. If the current value is already present in the recursion, means there are a cycle, we will return true. If visited, means it is already visited, we will return false. Otherwise, we will mark visited true. We will mark recursion current true. And for each neighbor, we will make a each cycle request for its neighbor elements, all neighbor elements. Then at returning time, we will make the recursion stack and we will remove the value from the recursion stack. If the work is done, we will return false, means there are no cycle. So if there are no cycle present, then we will further proceed. We will make visited empty, and for each element we will make a topological sort, topo sort. So in topo sort, what we will do, we will make our visited, means item is visited true, and for each neighbor in the adjacency list, we will make a DFS request for topological, means its next topological element. So in this way, we will push the value in the current, means we will add the value into the current. After that, we will add our stack value. We will pop from the top and we will add into the stack. So in this way, we will add into the stack. Then result array, we create an array because we have to return the integer array format. Though we create an array of result size, and from I we will add the value into the our result array. Then we will return the value. So this is how we will solve this problem. So you can see beats 91.8% of user. So great.